This video is sponsored by Brilliant. Hey guys, this looks like a fun one. We're given 7 quarter circles inside of a semicircle. And it wants to know what fraction of the semicircle do the quarter circles cover? Or in other words, it wants the fraction of the area of this divided by the area of this. This is day 14 of the 2025 Advent calendar. And it's my goal to solve all of these by the end of February 2026. And if you want to try this one, pause it right now, because I'm going to solve it in 3, 2, 1. Each of these quarter circles have the same radius. Let's label it little r. And then for the whole semicircle, let's label the radius big R. And now we can write a formula for the numerator and the denominator. The numerator is made up of 7 quarter circles with a radius of little r. So it's going to be equal to 7 times 1/4 pi little r squared. And then the denominator is going to be a semicircle with a radius big R. So it's going to be equal to 1/2 pi big R squared. And I think there's a way we can tie these together. This diameter is equal to 2 big R. And this portion of the diameter is equal to 4 little r. 1, 2, 3, 4 little r's. And then this portion of the diameter is something we don't know. Let's call it x. So now we know that this diameter is equal to 4 little r plus x. So the radius big R is going to be equal to half of this diameter. Or in other words, 4 little r plus x, whole thing divided by 2. So in the place of this big R, we can plug in the 4 little r plus x over 2. And now we can write a nice equation for the entire fraction. It'll be equal to this over this. And this is what we're trying to solve. Let's put a box around it. And now for the next step, let's find this intersection point and draw this perpendicular to the diameter. And we know the length of this segment. It is exactly 2 little r. 1, 2 little r's. And then we can draw the segment from here to here and from here to here. This is also going to be perpendicular because it is an inscribed angle that contains a diameter. Here's some notes right here. And now we've created 3 similar right triangles. We have the small one here, the medium one here, and the large one here. And then we can use these notes here to set up this proportion. The notes are showing us that anytime you have 3 similar triangles set up inside of a semicircle like this, you know that this over this equals this over this. So we have 4r over 2r equals 2r over x. And then we can simplify from here. On the left-hand side, the r on top and the r on bottom can cancel each other out. And 4 divided by 2 is equal to 2. And now to get rid of the fraction on the right-hand side, we can multiply both sides of the equation by x. The left-hand side is going to be equal to 2x, and the right-hand side is going to be equal to 2r. After we divide both sides by 2, we get x is equal to r. That means in the place of this x, we can plug in r, and in the place of this x, we can plug in r. And now we can simplify this. Inside of this parentheses, 4r plus r is equal to 5r. And then the square will go to the 5, the r, and the 2, giving us 5 squared r squared over 2 squared. 5 squared is equal to 25, and 2 squared is equal to 4. And then from here, 2 times 4 is equal to 8. And then on top, 7 times 1/4 is equal to 7/4. And then we can rearrange things like this. From here, the pi r squared on top and the pi r squared on bottom are going to cancel each other out. So we end up with 7/4 divided by 25/8. Let's rewrite that as 7/4 divided by 25/8. And that's going to be the same thing as 7/4 times 8/25. You just got to flip the second fraction. And then using the commutative property of multiplication, we can swap the 7 and the 8. 8 divided by 4 is equal to 2, and 2 times 7 is equal to 14. And that is the answer to our fraction. In this given problem, the fraction of the 7 quarter circles over the 1 semicircle is equal to 14/25. There's not going to be a label, but we can put a box around it. How exciting. I had a lot of fun solving this problem. And if you want to fine-tune your skills so you can solve problems like this, Brilliant has you covered. You're going to like how fun it is to learn with the interactive lessons and the awesome hints and explanations. Over the past week, I revisited the 100 Days of Puzzles. I thought the most interesting puzzles were going to be last, so I went backwards. It turns out all of them were interesting. For question 1 of level 1, here it is right here, I did get the right answer by choosing arbitrary values, but there was a really cool precise solution that I didn't find. They explain it right here. I didn't realize you could get the solution this clean. And then the same thing happened with this one. I did get it right, but I didn't find the elegant solution that they have right here. And I really like this one because of this simple interactive tool. It enables you to test the different scenarios right on the screen. It made it fun to visually see why some of the scenarios had contradictions and why the final solution ended up working out. And then this one reminded me of a simple math fact that I totally forgot about. And I can comfortably say after going through this problem, I will remember this math fact for a very long time. I'm even thinking about making a video about it. If you want to try Brilliant for free for a full 30 days, visit brilliant.org/andymath, scan the QR code on the screen, or click on the link in the description. If you use this link, Brilliant is offering 20% off a premium plan. It'll give you unlimited daily access to everything on Brilliant. How exciting.